Welcome to another important lesson, Supercharger. It's time to dive in deeper into color topics. In this lesson, we'll cover the basics of a color wheel and the way we group colors for UI design purposes. The color wheel is a visual representation of primary, secondary, and tertiary colors, which are arranged in a circular format. By understanding the color wheel and its various color combinations, we can create visually delightful and effective user interface designs. There's one important thing I'd love to stress before we move on further, and it's something I see UI designers often get wrong. In online use, we use the RGB color wheel, not the red, yellow, blue one you might have learned about in school, since we design for screens. Understanding how screens display color is essential for UI designers, as it affects the way colors are perceived and presented in digital interfaces. The RGB color model is the primary color model used in digital screens. We'll talk more about this topic in the next lesson, but in short, it stands for red, green, and blue. Those three colors are the primary colors used to create all other colors on the screen. The RGB model works by combining different intensities of these three hues to create a full range of colors that can be displayed on a screen. Screens display color by emitting light. Each pixel on a screen is made up of 3 subpixels that emit light in different intensities of red, green, and blue. By combining different intensities of these 3 colors, we get all other colors that can be displayed on the screen. Another thing you should keep in mind are color gamuts. Color gamut refers to the range of colors that a screen can display. Different screens have different color gamuts, which affect how colors are perceived and displayed. For example, some screens have a wider color gamut, which allows them to display more vivid and accurate colors, while others have a more limited color gamut. You might have noticed that colors don't always appear the same on your computer screen and your smartphone, for example. To ensure that colors are displayed accurately on a screen, it's important to calibrate the screens. This is especially important for designers, as it affects the way colors are perceived and presented in digital interfaces. Now that we have a full understanding of how screens work, and now that we know why that's important for us as designers, it's time to get back to the main point of this video. As I already shared, in online use, we use RGB color wheel, not the red, yellow, blue one. It works better for RGB screens we design for, and it works better with how hue is separated into 3 120-degree ranges on the color wheel. If you remember the cones we have in our eyes, the ones I mentioned in one of the previous lessons, we have 3 types of cones: blue, green, and red. That's also why it's important to think about color from the perspective of red, green, and blue, not yellow, blue, and red. That makes red, green, and blue the primary colors for UI design. If you combine all 3 of these colors, you would get white. If none of them are present, you get black. These colors are the building blocks of all other colors and cannot be created by mixing other colors. If we take a look at a hue color wheel, red is at 0 and 360 degrees, green is at 120 degrees, and blue is at 240 degrees. By combining 2 out of 3 primary colors, we can create secondary colors. For UI purposes, secondary colors are cyan, magenta, and yellow. By combining blue and green, we get cyan. By combining red and blue, we get magenta. And finally, by combining green and red, we get yellow. Once again, if we look at a hue color wheel, yellow is at 60 degrees, in between red and green. Cyan is at 180 degrees, between green and blue, and magenta is at 300 degrees, in between blue and red. For the tertiary colors, we need to take a look at all 30 distances on the color wheel not taken by primary and secondary colors. At 30 degrees, we have orange. You can think of it as combining red, a primary color, with yellow, a secondary color. At 90 degrees, we have chartreuse color, more commonly known as yellow-green or greenish-yellow. It is the result of mixing a primary color green with a secondary color yellow. At 150 degrees, we have a spring green, sometimes even called emerald, a bright blue-green color. It's a result of mixing green with cyan. At 210 degrees, we have azure, a color mix from the primary blue and the secondary green. At 270 degrees we reach violet purple, a color mixed from primary blue and secondary magenta. And finally at 330 degrees we reach a rose pink color, the result of mixing a secondary magenta with a primary red. This means that the 6 tertiary colors for UI design are as follows: orange, chartreuse, spring green, azure, violet, and rose pink. We can also categorize colors in a different way, not just through primary, secondary, and tertiary. Another way to do it is to group colors under warm and cold categories. Warm and cold colors are important consideration for designers, as they can have a significant impact of how users perceive and interact with a digital interface. Warm colors are colors that are associated with warmth, energy, and excitement. These colors include the shades and tints and tones of red, oranges, and yellows, which are all colors that are associated with sun and fire. In UI design, warm colors can be used to create a sense of energy and vibrancy. For example, using warm colors in a call to action button can create a sense of urgency and excitement. Similarly, using tints of warm colors for backgrounds can create a sense of comfort. Cold colors are colors that are associated with coolness, calmness, and relaxation. These colors include the shades, tints, and tones of blues, greens, and purples, which are all colors that are associated with water and nature. In UI design, cold colors can be used to create a sense of calmness and serenity. For example, using cool colors in a website design for a meditation app can create a sense of relaxation and tranquility. Similarly, using cool colors for a call to action button for a financial app creates a sense of trust and security. The use of warm colors in the Airbnb primary palette creates a sense of excitement and adventure. The use of cool colors in the Twitter application creates a sense of calmness and trust. To sum up, warm colors are associated with excitement, energy, and passion, while cool colors are associated with calmness, relaxation, and trust. Warm colors are eye-catching and they tend to stand out more in interfaces. They're energetic and positive. Cool colors tend to fade into the background of interfaces. Understanding how we group and perceive colors is another crucial step you just completed on your way to color mastery. Congratulations, and thank you for completing another lesson.